In this tutorial, we're going to solve a question on Hooke's law. Question 9, page 22 in the book. The question says, the information in the following table was obtained from an experiment with a spring of original unstretched length 5 centimeters. So what we did is perform Hooke's law, and on each load we would measure the length of the spring with an original length 5 centimeters. So, part A. Copy and complete the table by calculating the extensions produced by each load. So what we have to do here is get the extension, which is the length that the spring reached after adding the force. In the initial state, the length was 5 centimeters. There was no extension because the extension of a spring equals stretched length minus unstretched length. So 5 minus 5 equals 0. Now let's move on when the load force is 2 Newton. We have a 5.8 length of the spring, so 5.8 minus 5 equals 0.8. We repeat that for all of the forces. 6.5 minus 5 equals 1.5. 7.4 minus 5 equals a 2.4. 8.3 minus 5 equals 3.3. 9.7 minus 5 equals 4.7. And the last load, 12 Newton, 12.9 minus 5 equals 7.9. Use your table to draw a graph of force, y-axis, against extension on the x-axis. So now that we got the extension, we're able to draw this graph. We have on the x-axis the extension and the unit is centimeter. And on the y-axis we have the load force and the unit is Newton. So now let's choose a scale. The smallest number in the extension is 0 and the largest number is 7.9. And in the load force we have the smallest number 0 and the biggest number 12. So we can choose the scale as follows. 1 centimeter for each centimeter for the x-axis and the y-axis, 2 Newton for each centimeter. Let's start to plot the points on the graph. We have the point 0, 0. Then at 0.8 we have 2. When x was 1.5, y was 4. At 2.4, y equals 6. At x equals 3.3, y equals 8. X equals 4.7, y equals 10. And the last point at x equals 7.9, the y equals 12. Now let's draw the line. We notice that it is an increasing straight line up to point. So part C. Mark on your graph the part that shows Hooke's law. The part that marks Hooke's law is this one right here, since it is a straight line, an increasing straight line. Part D. On the same axis, sketch the shape of the line you might get if you carried out the same experiment using a rubber band instead of a spring. If we use the rubber band in this experiment, we'll get a line that almost looks like this.